Have you ever wondered what magnetism really is? Most of us think of magnets as those mysterious objects that stick to the fridge or make compass point north. But magnetism is much more than that. At its core, magnetism is a natural force, one of the fundamental forces of nature created by something very simple: moving electric charges. Think about electricity flowing through a wire. When the tiny particles called electrons move, they create an invisible force around the wire, a magnetic field. This invisible force can pull or push certain materials, like iron, and even affect other magnets. So magnetism isn't just about magnets. It's about how electric charges move and interact with the world around them. Understanding the simple idea is the key to unlocking the many wonders of magnetism. Now that we know magnetism comes from moving electric charges, let's talk about something even more interesting: magnetic fields. A magnetic field is an invisible area of influence that surrounds the magnets or any moving electric charge. You can't see with your eyes, but it's there, and it can make things happen, like pulling a paperclip towards a magnet or turning the needle of compass. Imagine the magnetic field like an invisible web or force field around a magnet. Scientists often show this field using lines called magnetic field lines. These lines flow from magnet's north pole to its south pole, showing the direction and strength of the force. The closer these lines are, the stronger the magnetic fields in that area, and the field is stronger near the magnet's poles. That's why the ends of magnet are the most powerful. Even though you can't see magnetic fields, you can see their effects everywhere: in compass, electric motors, and even in the earth itself, which has a huge magnetic field protecting us from solar radiation. So, what actually creates magnetism inside materials and wires? Let's zoom into the tiniest levels, the atoms. Inside every atom, electrons move around the nucleus. But here is something fascinating. Electrons don't just orbit, they also spin like tiny tops. Both their spinning and orbiting create tiny magnetic fields, almost like miniature magnets inside each atom. In some materials like iron, these tiny magnetic fields from many atoms line up together in the same direction. When that happens, their magnetic forces add up, creating a much stronger overall magnet. This is called ferromagnetism. And it's why iron can become a permanent magnet. Even when electrons flow as electric current in a wire, their movement produces a magnetic field around the wire. So whether it's tiny atomic spin or moving charge in a wire, magnetism is always about the behavior of electrons. Not all materials respond to magnetism in the same way. Scientists have found that magnetism comes in different types, depending on how the electrons inside behave. First, there is ferromagnetism, the type we are almost familiar with. Materials like iron, nickel, and cobalt fall into this group. Their atomic magnets line up strongly, which is why they can become permanent magnets. Then there is paramagnetism, where materials like aluminium or platinum are only weakly attracted to magnetic fields. Their atomic magnets don't line up perfectly, so the effect is much weaker and only shows up when a magnetic field is applied. Lastly, we have diamagnetism, materials like copper or bismuth that actually creates a tiny magnetic field in the opposite direction, causing weak repulsion. It's subtle, but it proves that magnetism is everywhere, even the materials we think of as non-magnetic. Understanding these types help us know why some things stick to magnets and others don't. Magnetism and electricity might seem like separate things, but they're actually two sides of the same coin. Together, they form what scientists call electromagnetism. When an electric charge moves, it creates a magnetic field. But here is the amazing part. If that magnetic field changes, it can create an electric current. This discovery, known as Faraday's law of induction, is the reason electric generators work. Think about a bicycle dynamo or a power plant. As magnets spin near coils of wire, they create electricity we can use to power our homes and devices. Motors work the same way, but in reverse. Electricity creates a magnetic field that makes things move. So, electricity and magnetism are deeply connected, constantly influencing each other. This connection is at the heart of much of the technology we use every day. Now that we understand what magnetism is and where it comes from, let's look at how it shapes our world. Magnetism powers electric motors in fans, washing machines, and electric cars. It's behind generators that produce the electricity we use every day. Without magnetism, the modern world wouldn't function. It's also at the heart of MRI machines in hospitals, helping doctors see inside the body without surgery. And in credit cards, there's magnetic strip that stores your data. Even your phone speaker uses tiny magnets to turn electric signal into sound. And let's not forget the Earth itself. Our planet has a giant magnetic field that protects us from harmful solar radiations and helps animals like birds and whales navigate. Magnetism is everywhere, invisible, but incredibly powerful. And now that you understand it, you'll start seeing it not just as mystery, but as a force that shapes our daily lives. So, what do we really mean by magnetism? It's not just about fridge magnets or compass needles. It's about the invisible force created by the motion of tiny electric charges, from the spin of electrons inside the atoms to the massive magnetic field of our planet. Magnetism is a quiet force that shapes the universe in powerful ways. It drives technology, powers machines, protects our planet, and reveals a deep connection between electricity and motion. Understanding magnetism isn't just about learning facts. It's about seeing the hidden structure behind how things works. And once you do, everyday objects start to look a lot more magical. Thanks for watching and stay curious.